We'll end this section talking about graphs as function. The graph of a function is a visual representation of all of its ordered pairs. The vertical line test can be used to determine whether or not a graph represents a function. The vertical line test says if any vertical line intersects a graph more than once, then the graph does not represent a function. Otherwise, the graph represents a function. In example 4, we're asked to use the vertical line test to determine whether the graph represents a function. So here's our graphs that we have in example 4. So example 4a, we have this graph. To use the vertical line test, we want to look and see if we can draw anywhere a vertical line that hits the graph more than once. And there's many places where you can draw a vertical line and hit the graph more than once. So we would conclude that this is not a function. Example 4b, this graph, again, to use the vertical line test, we want to see if there's anywhere on the graph that you can draw a vertical line and hit the graph more than once. Okay, anywhere that you try, you'll only be able to hit this graph once. Okay, so we would conclude that yes, this is a function. There's a lot of information that can be obtained about a function by looking at its graph. We will learn some of those things in this section and more in the next section. Some of the things we can observe about a function from its graph are the domain and range, function values, and intercepts. Some of the other things we'll learn in the next section are maximums and minimums, and also where a function is increasing and decreasing. In example 5, we have this graph, and we are asked to state the domain and range of this function, as well as to find the function value at 1. Okay, so first, the domain. Remember, domain refers to the first component, and a graph always has points as x comma y. So the domain is referring to the x values. So to answer a question about a domain, we want to see what the furthest left our graph goes to. So the furthest left is this point right here. We don't want to look at the axis, we want to look at the actual function. Okay, the furthest left the function ever gets to is right here at 2. Okay, or negative 2 rather. Okay, at negative 2 you have a filled in circle. That means that point is included in the graph. So for the domain, it starts at negative 2 and ends right here. That's our furthest point to the right, and that happens at x equals 1. So the domain in interval form is negative 2 to 1. Okay, in set builder or inequality form, we would have negative 2 less than or equal to x less than or equal to 1. The range is referring to the y value. And to find the range, we want to see what's the furthest that our graph goes down and what's the furthest that our graph goes up. Again, we're not looking at the scale, we're looking at the actual function. Okay, so the lowest that my graph ever reaches is this point right here. And that point is when y equals 0. So my range starts at 0. And the highest my graph ever gets is this point right here. And that's happening when y equals 3. So my range is from 0 to 3. And again, we're using brackets because we have filled in circles indicating that those points are included. Set builder or inequality notation would be 0 is less than or equal to x less than or equal to 3. Part C of example 5 asks us to find f of 1. Remember what that means? It's telling us that the x value is 1, and we need to express what the y value is when x equals 1. Okay, so if we go to x equals 1, and we find where our function is here, and that corresponds to a y value of 3. So f of 1 equals 3. Okay, example 6, we have a graph, and we're asked to find the domain and range of this graph. Okay, so the domain is the x values, and again we want to see what's the furthest left that our graph goes, and that's right here at x equals -2. On this function though, we have an open circle, and an open circle means that that point is not included in the graph. The graph gets as close as you would like to that point, but it's not actually included there. So here we'll say our domain starts at -2, but with a parentheses because x never reaches -2. The furthest right that our graph goes is here, and that's happening at x equals 1. Okay, this one has a filled-in circle, and so we will use a bracket to show that x actually equals 1. Our range, y values, we want to see what's the furthest down our graph goes, and that's this point, and that's happening at y equals -1. And it's a filled-in circle, so we'll use a bracket at -1. The highest that our graph goes is to y equals 2 at this point, and we have an open circle, and so we'll use 2 with a parentheses. Example 7, we're given this graph, and we are asked to find 5 things: domain and range, f of -2, and the x-intercepts and the y-intercept. So let's start with domain. Okay, domain is the furthest left that our graph goes. So if we go to the left, our graph stops here, okay? But since we don't have open and filled circles, if your graph ever reaches the boundary of the graph window, it implies that the graph continues in this direction forever. So it's trailing down and to the left. Okay? What's also common is to see arrows at the end of the graph like this. Okay? But it tells you your graph is going down and to the left forever and ever. So there is no smallest value to the left. It's -infinity. As I travel to the right, the furthest that my graph gets to the right is here. And again, it makes it to the end of the graphing window, and that's implying that the graph is going to continue in this direction forever, up and gradually to the right. So there is no largest value to the right, it's infinity. The furthest down that my graph goes, my arrow has me continuing down, and so like domain, the range, -infinity is the smallest y value, and traveling up, infinity is the greatest y value. Our third question, what's f of -2? Remember, that's telling you x is -2, and you're being asked to find the y value when x is -2. If we go on our graph, here's x equals -2. If we go up, the graph is right here, and that's at a y value of 4. So f of -2 equals 4. Part D asks you to find the x-intercepts. The x-intercepts are the places on the graph where the graph crosses the x-axis. Okay, so places we cross the x-axis are here, here, and here. So we have x-intercepts at -3, -1, and 2. Often we'll write those in ordered pair format. If we're on the x-axis, that means we didn't go up or down any, and so our y value at these points is 0. So the x-intercept -3 is -3, 0. The x-intercept at -1 is -1, 0. And the x-intercept at 2 is 2, 0. Okay, any graph could have 0, 1, or more than 1 x-intercepts. Last thing we're asked to find is the y-intercept. The y-intercept is the place on the graph where the graph crosses the y-axis. So our graph crosses the y-axis here at -6. So our y-intercept is -6, and just like x-intercepts, typically we write those in ordered pair format. If you're on the y-axis, that means you didn't move to the right or left any, and so your x-coordinate is 0. So the y-intercept in ordered pair format is 0 for x, comma, our y value is -6. For any function, you'll either have 0 or 1 y-intercept. You can never have more than one y-intercept, otherwise your graph does not represent a function.